talk about rational functions from lesson 8, and we're going to focus on transformations of rational functions. So transformations are when we do something to the parent function that causes the graph of the function to move somehow. So for a rational function, our parent function is f of x equals 1 over x. So anything we do to alter this is going to cause a transformation of the graph. So whether I multiply it by some constant, if I change the denominator by adding or subtracting a number, or if I add or subtract a value outside of the fraction, these are all going to cause changes to the graph. So if I do something in the numerator, it's going to cause a vertical stretch, a compression, or a reflection. If I add a value or subtract a value on the end, not part of the fraction, it's going to cause a vertical translation, meaning the graph is going to move up or down. And in the case of the denominator, if I add or subtract a value, I'm going to have horizontal translation. I'm going to move left or right. So this table can be found in lesson 8, and you can see that I've written it down in my own way. I think this is helpful to me. And as I do each problem, I'm just going to keep this key on the right-hand side of the screen to help me out as I go along. So remember, we're comparing everything to this parent function f of x equals 1 over x. And we're just going to say what is different about the function that we're considering versus that parent function. So for example, the first function is f of x equals 1 over x plus 5. So notice that the difference is that I've added 5 here, and there's no plus 5 there. So that's it. That's all we're doing differently. Now I look at x plus 5, and I say, okay, so the denominator is different. So I look at my key, and I say, what happens when I change the denominator? Notice that I move left. Here's my key that says about h. I move left when h is less than 0, and I move right when h is greater than 0. So what's the value of h here? The value of h is negative 5. Where did I get that from? Notice that here I'm subtracting an h. Here I added a number. So really what I have is x minus negative 5. And in fact, I encourage you to rewrite that every time so that you always have that subtraction in the denominator. This is really x minus negative 5. Now that matches the form of x minus h, and it's easy for me to see that h is equal to negative 5. Now I know that that is less than 0, which means that my function is going to move to the left 5 units. And again, I found all that just by consulting my key. Let's do it again with the next example. So in this case, I've got f of x equals 1 over x minus 6. So what's the difference between this function and my parent function? Well, 1 over x, here I've subtracted 6. That's something I didn't do up here. So I look at 6, at negative 6, and I look at my key. What variable does it fit with? Well, looks like k, right? So now I read the key. What happens when I have a k? Well, I move down when k is less than 0, and I move up when k is greater than 0. So what's the value of k? Well, it's negative 6, right? So here I'm adding a k. Here I am subtracting. So k equals negative 6, which means I move downward because k is less than 0. I move downward 6 units. Let's keep going. So in this case, I have got negative 1 over x. So what's the difference here? Well, I'm multiplying by a negative 1 instead of a positive 1. So I've multiplied the numerator by something. I need to identify a. A is equal to negative 1. Now I'm looking at my key here. Because a is still just 1, the absolute value of negative 1 is 1, I'm not actually vertically stretching or compressing, because if you vertically stretch or compress by a factor of 1, you just end up with what you started with. However, notice that because a is less than 0, I'm going to reflect across the x-axis. So the only thing that's happening here is that the function is being reflected across x. Let's keep going. F of x equals 1 over x minus 4. What's happening here? Well, our numerator looks fine. We're not adding anything outside of this fraction, but I have subtracted 4 in the denominator. Notice that this, x minus 4, matches the form here, x minus h. So I need to identify h. H is equal to 4. okay? H is equal to 4. And if you don't understand that, please take a moment just to look at the key and notice how 4 and H match up. I have an x minus 4 and an x minus H. So H is equal to 4 here. Now I consult my key. Notice that I'm moving left if H is less than 0 and right if H is greater than 0. Well, here H is greater than 0, so I'm going to move right 4 units. Alright, let's keep practicing. So sometimes more than one transformation can be happening at once. So once again, we're going to compare all this to 1 over x, and we're going to say, what's happening? What changed here? Well, in my first example, notice that I'm multiplying by a negative 1, so I've affected a. So a is equal to negative 1. Again, that doesn't actually cause vertical stretch or compression because the absolute value of negative 1 is just 1, so nothing happens. However, I am reflecting across the x-axis because a is less than 0. Now, I've also added 8 to the denominator. Notice that that affects h. Remember, it's helpful to always rewrite denominators in the same form as x minus h here. So I'm going to rewrite this as a subtraction, and I get x minus negative 8. That makes it really easy to identify that h is equal to negative 8. Now, according to my key, I move left when h is negative. So that means I'm moving left 8 units. Combined, I'm moving 8 units left, and I'm reflecting across the x-axis. So that's what's happening here. Let's look at the other example. So in this case, we've got 1 over x minus 3 plus 7. So what's changed here from the original 1 over x? Well, I've added 7, and then I've subtracted 3 in the denominator. Let's look at that x minus 3 first. So what is h going to be equal to? Notice that because it's written as a subtraction problem, we don't have to do any work really to identify h. We see that h is equal to 3. Since h is equal to 3, that means that h is greater than 0. If h is greater than 0, we move right 3 units. But that's not the only thing that's happening. We also have to find k here. So the 7 in this case is our k. Notice that it's a positive 7. So we move down when we've got a negative k, but we move up when we've got a positive k. So when we combine these, we find that f is going to move 7 units up and 3 units to the right. So those two transformations are taking place. Let's keep going. Alright, so say we have f of x equals 1 over x minus 9 plus 2. Again, we're just comparing to 1 over x. What's different here? Well, I'm subtracting 9 in the denominator and I'm adding 2. So that means I'm going to have to find a k and an h. So let's start with k. Notice that 2 is positive, and if 2 is positive, we move upwards. We're going to move upward 2 units. Now what about h? I've already got x minus 9 written in the correct format. It's already written as a subtraction. So h is equal to 9. If h is positive, we move right. So when we combine those, we're moving 9 units to the right and 2 units up. So we're going to add on to this. What about identifying the domain, range, and asymptote of a function? So notice that I've got the same setup here. And this time I'm going to use k not just to identify vertical movement, but it's going to tell me where my horizontal asymptotes lie. Horizontal asymptotes. Remember, an asymptote is a value that your graph approaches but never reaches. So for example, if you had an asymptote of y equals 1, let's see that this is the line y equals 1, you may have a function that seems like it will eventually hit y equals 1, but never actually will. This would be our asymptote. So k is telling me that there is a horizontal asymptote at the line y equals k. So whatever the value of k is, means that there is a horizontal asymptote. Similarly, h is going to tell us where our vertical asymptotes are. So whatever h is equal to tells us that there's a vertical asymptote at the line x equals h. So this time, we could still identify, if we wanted to, the transformations that are taking place, but we're going to focus on the asymptotes. So for example, notice that I've got a plus 5 in my denominator. That means that h, if I rewrite this as a subtraction, it's easy to see that h equals negative 5. Remember, there's a vertical asymptote at the line x equals h, meaning if h equals negative 5, x equals negative 5 is going to give us a vertical asymptote. If you wanted to be a superstar, you could also tell me that this would also cause a translation left 5 units. Okay, building on what we practiced before. But let's just stick to asymptotes for now. So what about this other one? F of x equals 1 over x minus 2 minus 6. I'm subtracting 6 over here, and I'm subtracting 2 in the denominator. So, oops, I got ahead of myself there. So, I neglected my horizontal asymptote. So notice that, and this is important, so let's go back. Notice that I didn't add anything, right? There was no k value. So k was just equal to 0, right? I wasn't doing anything. That there is still a horizontal asymptote that exists. So if you just have a fraction that has no k value, you still have a horizontal asymptote. If k is equal to 0, then my horizontal asymptote is at y equals 0. Alright, moving forward. Let's talk about f of x equals 1 over x minus 2 minus 6. So again, starting with h, I've got this written in the correct subtraction form, so that means that h equals 2. If h equals 2, that means that there is a vertical asymptote at x equals 2. Now I've also got k. K in this case does have a value that's easy to see. It's equal to negative 6. So I've got a horizontal asymptote at negative 6. Now, if there's an asymptote, again, that was that value that it looks like your function will reach, but it never actually does. So if there's an asymptote, that means that that value is never going to be a part of your domain or part of your range, right? Because domain is all the values that x is going to equal, your range is all the values that y are going to equal. So if I have a vertical asymptote at x equals negative 5, that means that x equals negative 5 is not part of my domain. So if I read this, it says that the domain of this function is x such that, this bar is read such that x is not equal to negative 5. Similarly with range, if I have a horizontal asymptote at y equals 0, then y equals 0 is not part of my range. Down here, I had a vertical asymptote at x equals 2, so x equals 2 is not part of my range. And here I had a horizontal asymptote at y equals negative 6, so y equals negative 6 is not part of my range. I have to explicitly write that y is not equal to negative 6. Let's practice that a couple more times. So, notice that I have this addition in the denominator happening and this negative 5. So again, I find h, I rewrite this as a subtraction, so x minus negative 7, so h equals negative 7, which means I have a vertical asymptote at x equals negative 7. K is equal to negative 5, I have a horizontal asymptote at negative 5. That means my domain is x such that x is not equal to negative 7, because there's an asymptote there, and my range is y such that y is not equal to negative 5, because I have an asymptote there. If f of x equals 1 over x minus 3 minus 1, I identify h. I've already got my subtraction in place, so h equals 3. So I have a vertical asymptote at x equals 3. K is clearly equal to negative 1, so I have a horizontal asymptote at y equals negative 1. This means my domain is equal to x such that I don't want x to equal 3, so x can equal 3. And my range is y such that y is not equal to negative 1. Again, because I have an asymptote at y equals negative 1. Alright, finishing up here. F of x equals 1 over x plus 11. So we've added 11 here, which means k, let's start with h. So In the denominator, I didn't actually change anything, right? I just had x. So that means the value of h is 0, because x plus 0 is still just x. So my my vertical asymptote is x equals 0. My horizontal asymptote I find by using k, which is equal to 11, so I have a horizontal asymptote at y equals 11. That means the domain of this function is all of x except when x equals 0. So I say x can't equal 0 because of my vertical asymptote there. And my range is y such that y is not equal to 11 because I have a horizontal asymptote there. So summarizing quickly, just use your guides here. So this whole time I've had some sort of guide or rubric on the right hand side on my screen to help me as I go along. It told me all the information I needed to know. So in this case I have the information about horizontal asymptotes and ranges and domains and vertical asymptotes. That's on the screen for me, and I've made it easy to identify. When we were talking about transformations, I had my guide for that on the right hand side, and I encourage you to do the same thing. Don't worry about memorizing this stuff. Just take good notes, make sure you understand your notes, and then use these keys as you work out these problems.